Good morning. Welcome to this lecture where we'll be looking at computer in organizations, CSS 735. So these are the scheme of work for this semester, which is Introduction to Computer in Organizations and Database Management System. Then the second topic is Information System and Management. Then third, we'll be looking at the cloud computing. Then the fourth, we'll be looking at business intelligence and analytics. We'll just be looking at the introduction session. Then here we'll look at the emerging trends in IT and their impact in organization. And then finally we'll look at networks and telecommunications in organization. Now we all know that this is the computer and organization class and we need to understand what is computer. So by default we know that computer is dummy and computer is an electronic device that is built to process information very fast. Now what is computer? So computer is an electronic device that process data and perform tasks according to a set of instructions, typically provided by softwares. Right? So, and we know that softwares, right, are built using programming codes, right? So it's like an instruction given to the computer to perform a specific task. And computer is an electronic device that processes data, right? So now we need to understand the types of software. Before that, we need to understand some basic hardwares in this so that you guys can be able to understand how the hardwares work, right? So the first one here, we're going to be looking at the physical part of the computer, and the one we'll look at here is the central processing unit, which is CPU. So this is the brain of the computer that performs instruction and processes data, right? So we have what we call the RAM, right? The RAM, which is the random access memory, which is a temporary storage for data that is being processed or used by the application, right? So the full name for this is random access memory. Right. So we also have another one which is the hard drive and the SSD. So SSD stands for the solid state drive. Solid state drive. So most of these systems, most of the current system we use now are being they come with the solid state drive because this is faster than the hard drive, right? So it's a long-term data storage for files, program and operating system. So it stores files, right? But this one stores files temporary. Like when you switch on the computer and process information, now this RAM is responsible for temporarily storing the data that is being processed or used by any application, right? So that is what this one does. And this one permanently store files in the computer, right? So when you like run in window or operating system on your system, right, on the computer, right? So it goes to this hard drive. So when you store most of the information permanently, it goes to the hard drive. So with the hard drive, you can be able to remove that hard drive or the solid state drive and then put it on that system. That is, if there's an OS here, right, you put it on that system and it will run, right? So it's this hard drive or the solid state drive is responsible for keeping your files permanently, right? So we have another input devices, which are tools for entering data like the keyboard, the mouse, and so many of them, right? That we can think of that pass data to the system unit, right? So this is the input devices. So the popular ones we know are the keyboard and the mouse. So we have other output devices, right? Like our printer or monitor, right? These are the output devices where you see the result of when the computer processes information. So the information being passed to the user and how the user see the results is from the monitor or from the printer when you print something out. So this is a good example of an output device, right? So the next thing we're going to be looking at here is the type of applications, right? Because we know that applications is responsible. I mean, software is responsible for passing instruction to computer to process a particular task, right? Because by default, computer is not intelligent, but it needs a software to process a specific task because it's fast, it's built to be very fast. So we need to understand the two types of softwares that we have. So the types of softwares we have is the application software, the system software, and the application software. The system software and the application software. So you can see from this diagram here, we can see that the application software needs the system software to run on a computer, right? It needs the system software to run on the computer. And we need to understand the type of system software. So the type of system software, one of the um, the main type of system software is the operating system. So we can see that system software is a type of software that provides the foundational layer for a computer's hardware to function and for application software to run, right? So we need the system software, right, to run the application software, right? So now one type is the operating system, right? So the common operating system that we use here in this country in Nigeria are the Mac OS, the Linux, and the Windows, right? So these are the common operating systems that we use here. And we also have the device drivers, right? The device drivers and also have the firmware. So the firmware is a software, right, that is stored in basic input output system responsible for performing the initial hardware checks and booting the system when the computer is powered on, right? So we need to understand the type of application software that we have. Application software of three types, which are the web application software, the desktop application software, and the mobile application software. So the mobile application software of two types, which is the hybrid mobile application software, which this is built on web technologies, web web technologies, and mobile wrapper. So we also have the native application software. Right, so we won't go that deep because this is just a computer organization class. We won't go that deep into the hybrid, we won't go that deep into native. But just get in mind that mobile of two type, which is a hybrid application software, which uses the web technologies. And the web technologies that it uses mainly are the hypertext markup language, right? The cascade and style sheet, then JavaScript, which are of different types, right, for front-end development. So like the Vue.js, the AngularJS, right, or the React.js. So anyone, most of the framework prefer, most of the framework use anyone, right? Most of the framework use either AngularJS or Vue.js or the React.js. So, but they are all JavaScript. So these are the basic web technology, HTML, CS, and JavaScript, right? And the mobile wrapper. And also, if you're doing a data-driven mobile application, then that is where we come up with a programming language, a full object-oriented programming language that we can use to design the APIs to link up the the mobile application and then with the database where it collects information from the front end and then takes that information and then send into the back to the database server where the database server processes the information and then returns it back to the user. So I won't go that deep into this class because this class is not a programming class. It's just an introduction to computer and organization. Okay. So these are the basic type of software, which are the web application softwares, right? Which we know about the web application software, right? It's a software that runs on the web, right? The software that runs on the web. So this desktop application software runs, it's natively installed in your desktop or your computer, right? So a good example of this is your Microsoft Office package that we use, right? That we use. And a good example of this, you guys, we all browse every day, right? We all browse every day. Let me give an example. We all browse every day. So, like the Nine University Portal is a good example of a web application software, right? So, but the desktop application, like a good example, is your Office package that you use is a desktop application software. The mobile application software, we all use most mobile applications very well. So, a good example is the WhatsApp that we use, right? It's purely native. It's WhatsApp that we use as a native application software, right? So there are so many of them, right? So just understand that these the application that runs on web falls under the web application software. Then the application that is natively installed in your computer falls under the desktop application software. then the mobile application that runs on your mobile phone, right? It can be an iOS or the Android operating system, right? Runs on the applications that runs on the iOS and also the applications that runs on Android, and there's also the applications that runs on both. A good example is a WhatsApp that we use, right? It runs on both OS mobile application, which is either Android or iOS, right? So let's now the application software plays a critical role in this technology framework, right? So enabling the users to perform specific tasks that address unique need of business, right? So you can see what happens, right? Because we need the application software to be able to perform our daily tasks. So it depends any kind of business that you're running, right? Any kind of business that you're running, you need a software, and that software falls under application software, right? So and the application software runs on system software. So we're going to be expanding on this as we move along, as we move forward on this topic here. So now we need to understand the key benefits of application software in organizations. The first one is data management and analysis, right? Data management and analysis. Applications designed for data management help organizations store, organize, analyze large volume of information. This capability enables data-driven decision making, leading to better strategic planning and resource allocation. Then the second we have is the enhanced productivity. So application software streamline various processes, allowing employees to complete tasks more effectively. Right? We have in our various organizations, we have different application softwares. One of the common and most popular application software that we use to process our daily tasks in many organizations today is the Office packages, which include the Microsoft Word, the Microsoft PowerPoint, the Excel, right? And so many of them that we use in as for people that are using the Windows operating system, right? So these desktop application software enables us to perform our daily tasks more effectively. And there are also many other softwares, many other custom built softwares, or many other enterprise softwares that are used by many organizations, right, to perform their daily tasks. Right. So the third one is to improve collaboration. So many application software solutions incorporate features that promote teamwork and communication. Right. So we have understood what software is. We have understood the operating system, the system softwares, which one of the a common type of the system software is the operating system. And the operating system for a computer, well, three common operating system for computer is the Linux, the Windows operating system, and the Mac operating system. Right. So, but for mobile application, we have two common operating system currently now, which are the Android operating system and the iOS operating system. Right. So these are the most popular operating systems that we use today. Right. So we have understood the key benefits of application software because of application software, we need a system software for the application software to run. And the application software of three types, which are the web development, the web application software, the desktop application software, and then the mobile application software. And we say that the mobile application have is either you're designing hybrid mobile application which runs on web technology or you're designing a pure native application software. Now we're going to be looking at the introduction to database management system here in this course, right? So now what is the database management system, which is a short name, abbreviation is DBMS. So database management system is a software that allows user to create, manage, and manipulate database. Right? It allows user to create, manage, and manipulate databases. So it provides an organization framework for storing, retrieving, and managing data in a structured way, ensuring that the data is accurate, secured, and accessible. So briefly, we'll look at the function of the database, right? So the first one we have is data storage, retrieve, and update. So with the aid of this database management system, we can store large volumes of data, allowing users to easily retrieve and modify it's using structured queries, right? But we're not going to be looking at the structured, although okay, we'll look at some of the simple basic structured query language here in this introduction to database management system. Yes, we'll look at that. Right, it's a simple one, so we'll not go that deep, right? Because in database management, relational database management system, that is what we'll look at here, right? So we'll not look at other types of database management system. We're going to be looking at the relational, what makes use of the tables and the relations, right? And we are going to be looking at the data manipulation language more here. We're not going to be looking at the data definition language because this class is not a database management class. So I'm just going to keep it simple, right? So now the second one is data security. Now DBMS provides mechanism to protect sensible data from authorized access through user authentication and access control. Now, during the installation of data, so it protects when you are installing it or when you're using it, right? So it protects unauthorized access through because we have roles and privileges, right? Especially when you're using a good relational database management system, we have roles and privileges. So it prevents unauthorized access through user authentication and access control, right? So now data integrity. Now the database management system ensures data consistency and accuracy by enforcing data validation rules, right? So such as constraints. So these are rules that's enforced, right? In order to that enforce on the data in order to ensure that consistency and accuracy. And we're going to be looking at some of the constraints here in this database course, right? So doing data entry or updates, we're going to be looking at what constraint means. So constraint are the rules, right? So now the last one we'll look at here is data backup and recovery. So the database management system offers tools for data backup and recovery in case of hardware failure or other data loss events. There are some relational database management system that requires you to manually set this, while there are some that automatically do they do this when you start using it, right? So, but there are some that automatically needs manually that need manual configuration to be able to do this. But almost all database management systems have this functionality, right? How this data backup and recovery. So now let's look at the type of database management system. We'll go through all the types, but the first one we're going to be looking at here is the relational database management system. Like I said before, makes use of the tables and relation. So you can see that the it stores data in tables, also called relations, right? With predefined relationship between them. So the SQL stands for the structured query language, which is commonly used for querying relational databases. And some of the examples of the relational database management systems are the MySQL, the PostgreSQL, the Microsoft SQL Server, the Oracle, and also we also have one the SQLite, and there are so many of them, right? There are so many of them, etc. So the other type we have is the NoSQL database management system, which is designed for handling unstructured data or semi-structured data. Right, we're going to be looking at what unstructured data or semi-structured data is, right? But the main scope of this class is we're going to be looking at this. We won't go down to all the types here. So it is suitable for large-scale distributed data storage, and real-time web application. This is also suitable for web application, right? It's also suitable for web application. So example is MongoDB, Cassandra, and CoachDB, right? And we also have the Azure Cosmos DB, Azure Cosmos DB, right? So, but we won't go that deep into the types, right? So, we just need to understand the basic and just need to know them. The third, we have the hierarchical database management system, which are organized. They organize data in a tree-like structure where each child record has only one parent. So example of this is the IBM information management system, right? So the fourth, we have the network database management system, which is similar to a hierarchical database management system, but allows each child to have multiple parents, forming a graph structure, which is the integrated data store. Then the last, we have the object-oriented DBMS, which stores data in the form of objects similar to object-oriented programming. So the one I want to we'll focus on here is the relational database management system, where we're going to be looking at some basic how this is relational database management system works. Right? So let's go to relational database management system. So the relational database management system is a type of database management system that organizes data into structured tables, also known as relation, where each table consists of rows and columns. Now, what is a table? Right? So a table consists of rows and columns. Right? So I'll just give an example. So let me do it here. So this is a table. So this is a table, right? So a table consists of rows. So these are rows. We have two rows here, which is one, two, three, and we have three columns, which is one, two, and three. So a table consists of rows and column. Now, what is a record, right? Now, what is a record? So these are records. So records are group of related data in a table, right? It's a collection of data in a table, right? So a collection of information in a table, right? So data, this is the data. Let's say we have ID, and let's say we have the employee name, and then we have the age, right? So what we call these are columns, or we call them attributes, right? We call them attributes. So these attributes describe the characteristics of this particular table. Let's say this table is called. So let's say this table is called. Let me insert this. Insert. So this is table one. So then this table is called the employee table. This is the employee table, right? So these are the attributes which describe the characteristics or the properties of this table. Which this table is an object, so the attributes are the properties, right, of this table, or we can call them the characteristics of this table, which are the ID, the employee name, the age. There are also more attributes that can make up this table, right? So now, if we have the ID one, this is a data. Okay, this is a data, right? This is a data. This is also a data. So if we have John, then we have age is 12. So this is a record, right? Now the records are the collections of informations, right, in the table. So let's say we have this is a row, or we can call it a tuple. Now this is a data, right? This is a data, and John is a data. So if we have Philip, then we have Philip is 30, right? So this is a data, this is a data, this is a data. Now the group collections of these data is records, right? Now this one John and this gives you what information. So this is the information about John, and this is the information about Philip. Now the collection of these informations are the records, right? So these are role, these are role, or we can call them tuple, right? And then these we can call the attributes, right? We describe the properties of this table. So let's look at the practical session, understanding the relational database management system, right? So this introduction to we're going to be looking at in the class we use access to be able to I introduce you guys to asset database management system where we create tables and relation and understanding the practical implementation of constraints and data manipulation. And we're going to be looking at this in the next video. So we're going to be looking at the practical tutorial in the next video. So the big understanding of our table is this, right? So, but let's understand the constraint here so that when we look at the practical implementation, we're going to be understanding what that does. So I've explained records, I've explained tuple rows, I've explained column attributes, then these constraints. Now there are so many constraints in this, right? There's so many constraints now. We have, okay, let me put it here. Okay, this is a table. So let me just insert. Okay. So in the constraint, we have the primary key constraint. The primary key constraint. So the primary key constraint here is, remember constraints are rules which is enforced on the data, right, to ensure for that consistency, right? So now the primary key here ensures that every data keyed here must be unique, right? So this is a unique identifier, right? Is a unique identifier. So let's say, so if we have the attribute ID, called employee name and age, right? And I want to enforce this primary key on one of these attributes here so that each of the data here will be unique here, right? So remember, I can choose to use the ID because every employee has a unique ID. So I can choose to enforce primary key to this particular attribute here, which is the ID, right? So you can see I've enforced the rule on this attribute so that every data that will be entering here, right, will be unique. So this is, I've enforced this, right, because for by rule, right, which would, although we'll not look at the normalization rule in this course, but just know that by default, every table must have a unique identifier, which is the primary key. Every table must have a primary key, right? So now this is a primary key, right? Every table defined, right, must have a primary key. So this is a primary key, right? So this primary key, you can see that we have the ID 1, which is the John, and we have ID 2, which is Philip, right? So you can see this is unique. So what it does is, if you enforce a primary key to this particular column here, right? So this particular column will not take this because this is a duplicate. So it doesn't take duplicates because it's a unique identifier, right? And also the primary key doesn't take null value by default, right? So if this place is empty, it will not allow you to key in Philip and it will not allow you to key in age 30, right? It means it doesn't take null value by default. That's why it's very necessary to enforce this attribute with the primary key so that every data here follows the rules, right? So that you have a neat and consistent database table, right? So remember that primary key takes unique value and primary key does not take null value, right? Primary key does not take null value and primary key does not take duplicate value. Now let's look at the other one. Let's look at the other constraint, which is the unique key. The unique key constraint. Now the unique key constraint is also a unique identifier. It's also a unique identifier, but what is the difference between a unique key and a primary key, right? You can see that a primary key here, once you declare this ID as a primary key, there is a name, there's a default. It can be, once you declare this ID as a primary key, now you can declare, you can declare a manual name, a manual constraint name, right? You can, let me not use the word declare. You can define a manual constraint name, or you allow the application software, which is the database management system, relational database management system that we're using. You allow the application software to to automatically define a constraint name for the attribute. So most of the time when we declare primary key, by default, the application software creates the constraint name. Now let's assume that the constraint name that application created for this particular attribute is PK ID employee, right? PK for primary key, PK ID employee. Now what this means that we can only have one primary key constraint in this table. Now, even if I want to combine one or more attributes to be a primary key here, let's say I want to combine this employee name and this ID to be the primary key, they will all fall under this one name, which is PK ID employee. Even if I want to combine the three, they will all fall under this PKID employee, which is the constraint name, right? That the application system knows. So we can't have PKID employee and also we can have PK have another constraint name PK in just one table. It doesn't work for primary key. So combining the ID, employee name, or any other column as a primary key is what we call the composite primary key. Is what we call the composite primary key, but it's actually not a good design. So it's really unnecessary to have more than one attribute as a primary key. So instead of that you can actually pick one which is the main primary key and make others unique key if you want to, right? So remember that the primary key is a constraint, is a unique identifier which you can define. That is, you can define a manual constraint name, or you can allow the application software, or you can allow the application software to automatically define a constraint for the attribute, right? So let's, like I said, we assume that the software define this name for this, and even if we want to add this as a primary key, then we need to add it under this name here, which this we only have one constraint name in this particular table. That is what it means. But in the unique key, we can have more than one constraint name in a table, right? So we can have, let's assume, because when you declare an attribute, let's say if you declare this attribute as a unique key, right? Let me use UK as a unique key like this. Let me use this abbreviation for unique key. So let's say you declare this attribute as a unique key, right? So let's assume the computer by default name this key UK employee name, right? So even if I want to add this age as unique, right, it will have a different constraint name, which becomes, let's say, for instance, computer can decide to name it UK age. Do you understand? So it means that we can have more than one constraint name for unique key in a table. That is one difference between the unique and primary key, right? So, but for the primary, remember the primary key cannot take null value by default. But unique key, if you are declaring this as a unique key can take a null value by default. By default, it can take null value, right? So that is different. And we can create relationship between primary key and a foreign key, that is the next constraint we'll be looking at, right? We can create relationship between two or more tables using a primary key and a foreign key, but you can't do that using a unique key, right? So now in this table here, where we have the ID, the employee name, and the age here, right? Where we have the ID, the employee name, and the age. Remember, we have declared this as a primary key, which is actually a U design, which means that every employee have a unique ID, right? Then here, this employee name, there's no need to declare this employee name as unique, right? There's no need to it doesn't make sense because unique by the it means that if there's another employee that bears John, for instance, right, it won't take it. It will take it, which there is every possibility that two employees may have the same name, right? But they should have different IDs. Yeah. So for age, declaring the age attributes, enforcing it to be unique, it doesn't actually make sense because there may be two or more employees that are of the same age, right? So if they're the same age and you declare this as a primary unique key, right, definitely it won't take it. It will throw an error. So now we have understood primary key, we understood unique key. Now let's look at the foreign key constraint. The foreign key constraint. So the foreign key constraint, right? What foreign key constraint means is a key that references another is a key that references another key and a primary key located in another table. Now let me give an example. Now you have this is a table, right? So let me have another table here. This is an employee table. So this is another table. So this is another table. Let's assume that this is employee table. So this one is, let's call this one, um, how do you call this one? Let's call this one employee office. So this table keep tracks of employee office, right? This table keep track of employee office. So I will have my ID here, then I will have the employee ID, right? And then I will have the office, the employee ID, then I will have the office. All right. So now this employee John ID is one, then Philip ID is two. So the office, let's say the office John office room 124, then this is room 125. Okay, now you can see what happens, right? So now in this table, this is an employee office table that keep track of employee offices. Then this is the employee table that keep track of the employee. Now this employee office table has one foreign key. Now what foreign key means is that foreign key is a key, right? Is a constraint or is a key that references another key, which is you can see is referencing a primary key in another table, and this table is called the employee table. Now the reason for this is to create the relationship between this table and this table. So instead of having employee name here John and so on like this, right, it's better you just uniquely identify the attributes with the unique ID here, right? So with that, the computer will be able to, the application software will be able to understand that this John, right, is this John, right, is located in room 124, or his office is in room 124, right? So now looking at this here, you can see employee ID, which is one. So he's referencing this ID, a primary key ID. So looking at this now, you can see that John actually, you can see that the employee, if you trace the ID, you will see that the employee is John. Now, if you trace ID 2 here, you see that the employee is Philip, right? So that is just the advantage. The advantage of this to create a relationship between these two tables. The primary key and the foreign key creates relationship between two or more tables. Right, we're going to be learning relationships like the one-to-one, one-to-many, and many-to-many when we look at the practical tutorials, right? Using the access, so we're going to be defining that, right? So now in this place here, you can see that we can see that the rule here is 1 to 1 as a employee to one office. It means that in this rule, right, so John cannot have two offices. But in some organizations, they have every possibility where John can have two offices, where John can have office can be located in room 124 and also have another office located in room 128, something like that. So in some organizations, I've seen that happen, right? Where a staff has two offices, right? I've seen that happen. While in most organizations, every a staff just have only one office. So it depends on the role of that organization. That is how you use to define this, right? So according to this one here, is like one-to-one relationship, right? One-to-one, so John to one-to-one. So we can have another John here with another room. So if you have another John here with another room, it won't be it will no longer be one-to-one relationship. It will be one-to-many relationship, right? So that is how it works. So now the next constraint we're going to be looking at, we've understood the primary key constraint, the unique key constraint, and the foreign key constraint. We're going to be looking at the null constraint, right? We have the null constraint. Now for null constraints, right? So remember, like we said before, that by default the unique key can take null value like this, right? So but if we apply the not null constraint to unique key, by manually apply the not null constraint to unique key, that means that particular data can be empty. So even if it's like this and this is unique, it won't take it because we have applied the not null. So it means that it shouldn't take any null value, right? So we also have more like the default constraint. We also have more like the default constraint. Now, this default constraint, when defining this table, right, using our structured query language, when defining this table, we can have the date. We can have an extra attribute called date created. So automatically, instead of inserting the date when John is being created here, by default, the application software will just create that particular date of when we insert this John records to this employee table, right? So that's what we mean by default constraint. There's also other many ways we can be applied to we can use default constraints. Like there are also many ways which in the practical sessions I will teach you guys how we can be able to do this. We also have another one which is check constraint. Now, most developers and most users apply the check constraints in let's say marital statute. Most I've seen where most organizations don't really like to use so many types of marital statutes like single, married, divorce, and so many of them. So many don't like using divorce, right? So you said that you are single or you're married. So now this check constraints will be applied to that particular attribute to check if what you're keying in is single or what you're keying in is married. So there are so many ways to also apply this check constraint, but these are not actually common, right, when defining database table. So the most common ones that most developers use are the primary key constraints, unique key constraints, and then the foreign key constraint. Now we have understood the basic understanding of this relation database management system. So in the practical session, we're going to be looking at how we can be able to do this practically. Now there are some assessment questions in this lesson one. You can see I urge you guys to study assessment questions because exam questions will be randomly be collected from the assessment questions for each lesson. So you can see where we have briefly explained the type of softwares and their type. So the type of softwares that we have, right, is the system software and application software. So you can easily briefly explain the types. So explain three key benefits of application software to organization, which we have mentioned in this video. So as what is relation database management system, we know that. Then what are the constraints? I just explained the constraints and said explain primary key because constraints are rules which are enforced on a particular column, right? So not to ensure consistency. So this is I said we should just explain the primary key, foreign key, and unique key constraints, which I've explained, then explain relations. So you can see from the lessons, you can be able to understand this, and this. Right. So in lesson two, we're going to although before we go to lesson two, we're going to be doing some little few practicals on this relational database management system. Thank you and God bless.